In the previous videos, I discussed how to formulate a data strategy. In these next few videos, I discuss how to develop governance around uses of ML and how to build successful ML teams. When you're implementing ML use cases, it's important to balance data access within your company against the security implications of that access. The most secure option is not to use the data at all. But if you want to acquire insights contained in the raw dataset, you should consider how to limit access to sensitive data. It's useful to train ML systems on a subset of the raw data or on the entire dataset after applying techniques to obscure the data. For example, you might want to train an ML model that uses customer feedback on a product, but you want to protect the privacy of people who submitted the feedback in the first place. The problem is, information such as delivery address and purchase history is critically important for training the ML model. After the data is provided to the data science team, they will need to query it for data exploration purposes. So it's important to protect your sensitive data fields before making it available. This type of dilemma is also common in ML models that involve recommendation engines. To create a model that returns user-specific results, you typically need access to user-specific data. Fortunately, there are techniques you can use to remove some sensitive data from the datasets while still training effective ML models. To help protect sensitive data in ML datasets, keep in mind the following 3 goals. Identify sensitive data in the dataset with a high level of confidence. Protect sensitive data without adversely affecting the project. This can be accomplished by removing, masking, or coarsening the data you have determined to be sensitive. Create a governance plan and best practices documentation. This allows your data engineers and customers to make appropriate decisions about your sensitive data, particularly those scenarios where the sensitive data cannot be identified reliably, masked, or removed. Sensitive data may occur in several forms. For example, specific columns in structured data sets, such as a set of columns containing a user's first name, last name, or mailing address. Unstructured text-based data sets that follow known patterns. For example, credit card numbers in chat transcripts. Free-form unstructured data such as text reports, audio recordings, photographs, or scanned receipts. Sensitive data in combination of fields. For example, a standard practice to reduce the likelihood of identifying a user is to blur the last 2 zip code digits, reducing the zip code from 5 down to 3. This is also called zip3. However, a combination of zip3 associated with work and a zip3 associated with home address might be enough to identify users with unusual work-home combinations. Similarly, a zip3 home address trend over time might be enough to identify an individual who has moved several times. This last bit requires statistical expertise. So work with your legal counsel and data science team to assess your exposure to risk in these scenarios. After you have identified your sensitive data, you must determine how to protect it. You could remove, mask, or coarsen it. There are several ways you can remove sensitive data. If the user-specific information is not necessary for your project, consider deleting all that information from the dataset before providing it to the data engineers who are building your ML model. When data is restricted to specific columns in structured datasets, you can create a view that doesn't provide access to these columns. The data engineers cannot view the data, but at the same time, the data is live and doesn't require any human intervention to de-identify it for continuous training. When sensitive data is part of unstructured content, but it's identifiable using known patterns, it can be automatically removed and replaced using a generic string. This is how the DLP API addresses this challenge. When sensitive data exists within images, videos, audio, or unstructured free-form data, you can extend the tools you've deployed to identify the sensitive data in order to mask or remove it. When sensitive data exists because of a combination of fields, and you've incorporated automatic tools or manual data analysis steps to identify the risk posed by each of these columns, your data engineers can make informed decisions whether to retain or remove any relevant column. When you can't remove sensitive data fields, it might still be possible for you to train effective models with the data in a masked format. If some or all of the sensitive data fields can be masked without affecting ML training, then several techniques can be used to mask that data. The most common approach is to use substitution cipher, which involves replacing all occurrences of a plain text identifier by its hashed and/or encrypted value.